Hello all, welcome to the next topic from electrostatics. So write down the next heading on your notebook, electric field line or electric force line. So write down the heading, electric field lines, electric field lines. This is also called as electric force lines, electric field lines, or this is also known as electric force lines. Okay, so here we are going to learn about some of the properties of electric field lines. What are the properties, what are the characteristics of electric field lines? In your school examinations, this may ask for like 2 marks or 5 marks or 3 marks kind of questions. But for entrance point of view, never by heart like, okay, I have to remember 10 points, I have to remember 5 points, nothing like that. You have to remember the concepts. Each and every point, what it is specifying, understand it, that's all. You don't want to recollect all the 5 or 6 points all together. Just understand what is each point is specifying, that's all. When questions will be coming, think about various possibilities based on certain diagram. Most of the questions are diagrammatic based from this area. We will see a few examples also. Before that, we will learn the concepts. Okay. So electric field lines or electric force lines, the properties of electric field lines and electric force lines. Number 1, first, electric field lines. So write down electric field lines going, in a simple words I am telling, going out of a positive charge, out of A or 2. So more than one charges is possible. So I am not writing out of A. So electric field lines are going out of positive charges. Very simple way. Okay, different textbooks are representing with the different sentences, but the concept is same. Electric field lines are going out of positive charge. Okay, so diagram is much simple. So if you have a positive charge, some plus q charge will be here like this, then electric field lines are always going out. Electric field lines are always going out, not coming inside. This already we have seen while we are deriving some parameters in the last sessions also, right? So electric field lines are going out of positive charges. Second property, electric field lines coming into the negative charge, just opposite, coming into the negative charge. So negative charge will have a property. If you have a negative q, minus q will be there. So the field lines are coming inside to the negative charge. So positive charge going away from positive charge, and for negative charge electric fields are coming inside the negative charge. So this is a second property. Okay, so we have to go to the third properties also. So I will rub these spaces. So okay, we can write here, then we will move to the next one. So electric field lines are going out of positive charge, electric field lines are going into the negative charge. The third property is electric field lines, very important, never, I am putting in capital to highlight is, never cross each other. Electric field lines will never cross each other. What this means? If I have a positive charges, for example, let me take an example for the third one. I have a plus q will be here, I have a minus q will be here. Okay, so electric field lines are going out and coming into the positive charges. So with respect to positive charges, electric field lines are going out, and with respect to negative charges, electric field lines are coming. If the charges are very nearer to each other, electric field lines are going into this one and going out of this one. So two lines I am drawing will be here, top side and bottom sides. Okay. So the electric field lines are never cross each other. So I can say this is a correct representation of the diagram I have drawn. If somebody will be drawing like this one, plus q and minus q, you have two charges, right? So one lines is going like this, other lines are going like this, next line like this, next line like this. Here it is a problem. Where the problems are happening? Because the electric field lines are crossing. At this point you can see electric field lines are crossing. Because of the crossing, this is a wrong diagrammatic representation of electric field line. So this is not correct, this is correct, because here crossing of electric field lines are there. That is not possible. Electric field lines crossing each other will not be possible. So that is a third point. Pause the video and draw the diagrams and write down the 3 points. Okay. So I will move to the fourth point. I will move to the fourth, 4, 5 points, the further points. So we are now 3 points we have learnt. Okay. Positive charges, electric field lines are going out. Negative charges, electric field lines are coming inside. Electric field lines will be never crosses each other. And the fourth point is electric field lines. You can write along with me, or you can first listen, then pause the video, then you can write. Electric field lines are always, very important this point, are always perpendicular, to the surface. Are always perpendicular. Electric field lines are always perpendicular to the surface. Let me take an example. Couple of examples I am taking. Suppose I have a rod will be here having positive charges. So electric field lines, if I am drawing the electric field lines with blue color, here electric field lines are always perpendicular, which means it will make 90 degree with the surface. Okay, electric field lines will be always like this. So if I am taking a circle like this, then always, if this is a metallic strip or a metallic wire, just so it's a wire, so always this makes 90 degree, this makes 90 degree, this makes 90 degree, always it should makes 90 degree with the surface, 90 degree with the surface. So this is an electric field line, this is also an electric, this all three are electric field lines, and which are always making 90 degree with the surface, which means it is always perpendicular to the surface. If somebody is drawn one electric field lines like this, for example for a conductor, if somebody is drawn like this one, then with respect to this surface, have not drawn anything will be here. Okay, suppose you can assume this is a hollow conductor. Okay, hollow conductor means no charges are inside. If no charges are not inside, means electric field will be equal to 0. So no electric field will be here. So before going to this one, let me tell you something. So this is an electric field lines. Here our concentration of the lines. So this angle is not 90 degree. This angle is not 90 degree. So this is not equal to 90 degree. Hence representation of the electric field line according to this diagram, it's wrong. According to this diagram, it is correct. According to this diagram, this is correct. So electric field lines always make 90 degree with the surface. That is the next point. And the fourth point we discussed, electric field lines always should be perpendicular to each other, perpendicular to the surface. And we are going to discuss about the fifth point. Fifth point, the electric field inside a conductor is equal to 0. This is also quite important. Electric field lines inside a conductor equal to 0. Suppose I have a conductor like this, a circle type, a cylindrical type conductors will be there. Then if I am asking you to draw the electric field lines, how you can draw? We know two conditions, electric field lines are always perpendicular to the conductor. Okay, so if we have a positive and negative plates will be here. So if I am drawing one electric field lines from here, so it should be 90 degree to the surface. So it should be 90 degree. It's exactly 90 degree, and there is no electric field lines are inside the conductor. So inside the conductor, electric field will be equal to 0. So here I can draw one electric field line like this. Okay, and if I want to draw further electric field lines, I can draw one line like this, but it should be makes 90 degree. So exactly like this. So now this will makes 90 degree. Similarly, I can draw another lines like this, and this will make 90 degree. So always it should be 90 degree, but as like this one, if I draw a straight line like this straight line is not 90. This straight line is applicable along the center portion, but when it comes to the side, we should have some small bending is required, then only this will make exactly 90 degree on both sides. Okay, so we need a 90 degree. So electric field lines are always perpendicular to the surface. So this is an example of an electric field lines which is passing over the conductor, and inside the conductor electric field will be equal to 0. Okay, so 5 points we have learned, and 5th point I am taking some space here and I am writing my 6th point. Note on my 6th point, write on electric field lines. Electric field lines never forms a closed loop. Never forms a closed loop. Electric field lines will never forms a closed loop, which means you cannot see an electric field lines like this, an electric field line like this. This kind of diagrammatic representations are there in your entrance examination question paper, then it is wrong. This is not a correct representation of the electric field lines. So if somebody is drawing the diagram of an electric field lines like this, then it is wrong. It's not possible. It's not possible. Okay, this is a 6th point. So we have discussed about the 6th point. Electric field lines emerges from positive and converges into negative point, and electric field lines are always perpendicular to the surface. Electric field lines will never crosses each other, and within a conductor electric field lines is equal to 0. Okay, electric field lines can repel each other. There are some cases are there also. So we will write it as our 7th point. So write down the 7th point. Electric field lines are the second one. Electric field lines can repel. 7th point. Electric field lines can repel. Write out the 7th point. 7th point. I'll write down in the board. Electric field lines. Electric field lines can repel. For example, let me take an example. Always diagram you will remember. Correct, whatever you study you will remember the diagram. So this means positive charges, electric field lines will be there, going out and going out and going out. But here also some lines are going out, right? For this also going out, this also going out. Whenever these two lines will be coming, these two lines cannot cross each other, cannot connect. So what will happen? These lines will go like this, these lines will go like this, these lines will go like this, these lines will go like this. Okay. Okay, and so electric field lines are repel each other. What that indicate? Can repel. It is not necessary it should always repel, can repel each other. Why? Because if two positive charges will be here, then the field lines from one charge and field lines from other charge cannot join. It is a kind of repulsion. So both will go like this. Okay. So 7th points also we have written. I will move to the 8th points. So what about the 8th points? The 8th point is representing the electric field lines are symmetrical about the line joining of the two charges. Symmetrical in the sense, let's write the point, 8th point. Electric field lines are symmetrical about the line joining of two charges. Let me take an example. Suppose I have a plus q, I have a minus q. Okay, so I have a plus q charge will be here. I have a minus q charge will be here. So the line joining of the two charges means this is the line joining. This is called line joining. It's a straight line. So with respect to this line, it is symmetrical. Symmetrical means if I have two lines like this, two electrical lines on top of this one, then definitely I have next two lines on the bottom. And remember, these two lines are not crossing each other, not forms a closed loop, and these lines will never crosses. These are parallel in nature. So these lines, this is called symmetrical. About the line joining, for your understandability, I am writing this is the line joining point. So this line is called line joining, and with respect to line joining, this is symmetrical, which means if you cut here, half portion top and half portion bottom are exactly pakka same, exactly same. That is called electric field lines are symmetrical about the origin. And my next point, the final one, I guess 8, 9, final one. So number of electric field lines are more for a charge. Number of electric field lines are more for a charge. More for a charge indicate magnitude of the charge is high. Magnitude of that charge is high. What this means to us? So if you have two charges will be here, let me take an example. If I have a plus 4q, I have a minus q. So plus 4q, I have a minus q. Okay, so sign, we know with respect to sign, if it is sign, positive sign means electric field lines are going out, and negative sign means electric field lines are coming in. But with respect to this charge, this is 4 times higher. Okay, 4 times higher. Suppose I am drawing 1 line, 2 lines, 3 lines, 4 lines like this one. Now here I am laying 1 line and 2 line and 3 lines and 4 lines. So with respect to this charge, listen very carefully, for this charge, how many field lines are there? It's easy, you can just count. Number 1, okay, how many field lines will be there? We will count this one, okay, number 1, number 2, number 3, number 4, 4 lines on the left side, right side, 5, 6, 7, 8. 8 lines will be there for this 4q. So I can say for a 4q, how many lines will be here? 8 field lines will be here. 8 field lines. Okay. For minus q, how many field lines are there? Minus q means the lines which are coming inside. 1, 2, 3, 4. So for minus q, 4 field lines are there. This is correct? This is not correct. Why? Because this 4 and minus q. So with respect to this charge, with respect to minus q, plus 4q is 4 times higher. 4 times higher charge means 4 times higher number of field lines should be here. Now here 4 field lines will be here. So how many field lines are required on this side? This is 4 times bigger than this one. So here 4 lines will be here, means if this is 4 times bigger means 4 times bigger number of lines are required. Totally now we have 8, but 8 is not sufficient. How much more we required? We required another 8 also. Now I am drawing the next 8 lines. So 1 and 2 and 3 and 4, 5, 6, 7, 8. So now this number 1, 2, 3, 4, 5, 6, 7 and 8. Now totally I have 8 black lines and I have a blue lines also 8. Now this 8 field lines instead of 8 field lines, what is the right answer should come for this one? It should have 16 field lines. Which means this charge with respect to minus q plus 4q is 4 times higher. 4 times higher means 4 times field line should be. So here it is 4. 4 into 4 is 16, which means plus 4q will have, we must have 16 field lines should be there if minus q will have 4 field lines. So a charge, we can say a charge strength, the magnitude of the charge will be higher or lesser. High amount of field lines means the magnitude of that charge will be higher. Okay, so totally 9 points we have learnt, and based on this concept, different examples, different concepts, different questions will come. Okay, I will tell you one example. Already we have discussed with the help of this concepts, and but still we will see one questions, which is how these examples are coming for entrance examination, how the questions are coming from this area. We will see it. So look into the board. Suppose I have a triangle shaped. I have a plus q, I have a plus q, I have a plus q. So for this they can ask you different options. Maybe I will draw 4 options. This is the field lines which are coming like this. Is this is correct or wrong? Can you tell me is this is correct or not? If you are looking to this diagram, this field line representation is correct or not? It is not correct. Okay, for from plus q lines are coming out. For plus q lines will never coming inside. Here these lines are coming inside. Here these lines are coming inside. Here these lines are coming inside, which means this is a wrong representation. Okay, they will give you a couple of options. They will give you 4 options, not only 1 or 2 options. They will give you a lot of options. 4 options, you have to choose the right one. So maybe I'll draw another set of diagram plus q. You have to tell it whether it is correct or not. Okay, so electric field lines are going out. Electric field lines are going out, and electric field lines are going out. 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 Is this is the right representation? This is also not the right representations, because tell me what is the reason? This is also here electric field, the field lines from this charges is crossed with this line. So here the fields are getting crossed. So whenever a crossing is happening, this is not a correct representations. Let me take another example, plus q and plus q and plus q. Sometimes I will ask you like this one. Okay, the electric field lines like this, something like this. So they'll ask you whether these field lines, these diagram representations are correct or not, something like this one. Is this is correct or not? This is 100% pakka wrong answer, right? Why? Because we have one point, electric field lines will never form a closed loop, will never form a like this kind of circle nature. So this is also wrong. So all this can get you as an options. Next we'll see plus q and plus q. Electric field lines are going out and going out, going out, going out, going out and going out, going out, going out, going out and going out, and here these lines are going out, and here one electric field lines are going out, one electric field lines are going out, one electric field lines are going out, one electric field lines from here are going out. Is this is right or not? This is right, right? You know, electric field lines are repelling each other. Concept is that electric field lines from a positive charges are always going out. There are no intersections, there are no connection, there are no closed loop, nothing. So this is actually obeying all our law. So this is the right answers will be here. So always remember. Okay, so this is one of my examples to you to understand how the questions are coming from this session for entry. Which of the following is the correct representation of the electric field lines? This is the correct representation. All the 3 on the top of these boards are the wrong representations. Okay. Okay. Let me go to the next example, example number 2. So I will draw 4 field lines. You have to say which one is correct one. So this is my first field lines like this. Okay, and this is my second field line like this. Number 2 is like this, and I have my third field lines like this, and I have my 4th field lines are also like this. So this is a solid conductor, or it's a conductor. Number 1, 2 and 3 and 4. Number 1, 2 and 3 and 4. Which of these following options are correctly representing the field lines? Number 1 is representing the field lines or not? It is not. You know the reason why. It's always should be 90 degree. This is not 90 degree. So 1 is not the right answer. This is not the correct answer. Second one, within a conductor, electric field will be equal to 0. So there are no field lines, something like in this bent format. So this is also wrong. Third one is also same. Electric field lines inside a conductor is equal to 0. We cannot draw any field lines inside the conductor. If we are drawing, that is a wrong, that is mistake. Fourth one, electric fields are making 90 degree. So that is correct. And any electric field lines are inside, no electric field lines, and it is going out with also 90 degree. So the fourth one is the right answer. All others are the wrong answer. So same kind of same model of questions will ask for entrance examinations, but understand the 9 properties. I have told you all the 9 properties are important. Okay, there are one more properties will be there, that is my 10th property, but related to that normally questions are not coming, but we have to know to solve for some of the derivations or some of the examples. So I will keep it as a last point of this sessions, that is a 10th point. Okay, you can write it along with that, or you can write it here, but it is not much to do with the questions what we have seen here. Here we have seen lot of questions, right, for the examples I am speaking. So it is nothing to do with the examples, but at the same time it is just a concept to understand, that's all. There are no questions will not see. For example, if you have a plus q, maybe we can put it as 11th point. 11th point, first we will write the points before we are going to the explanations. Tangent to the electric field lines, tangent to the electric field lines gives the direction of electric field. Tangent to the electric field lines will give the direction of electric field, which means suppose I have a plus q, suppose I have a minus q charge is also there. So let me take one electric field line like this. So this is the direction, this is a path of the electric field lines. So if you are asking what is the direction of electric field, I am marking 2 points, 1 and number 2 and number 3. If you are asking what is the direction of electric field intensity at the point 1, means I will draw a tangent. You know in mathematics called tangent. Tangent means two lines are grazing one over another. The red color lines are grazing on top of blue color line. So these lines are called tangent. So here the direction of electric field is like this, vector E. In position number 2, you can also draw a tangent like this, grazing. So here this is the electric field vector. In position number 3, you have to draw a tangent. So this is the direction of electric field vector. So electric field vector at different point will have a different directions, because the field lines are keep on changing. Whenever the field lines are keep on changing, each and every point you can draw a tangent, and that tangent is actually the direction of your electric field intensity. As like I told, this is a final point, but this is nothing to do with the examples what we have seen. Normally the questions which are coming for entrance examinations is not connected with the concept from here, but what are the concept we have learned up to the, this is the 10th point, right, till 9th point we have told. Okay, so 10th or 11th doesn't matter, concept is important. Okay, so this is not related to, nothing to do with the questions, but just understand there is something is like this. You can add whenever you are writing your board examination also, you can add all these points, 11 points, write it on your own words instead of by hearting as such from the textbook, understand the concept. So we have finished with the properties of electric field lines. Then we will move to the next sessions and the next topic. Okay, thank you.